And the final thing we are going to do from this chapter is integration by parts. So this, what we did, it's a substitution rule, or this is also known as integration by substitution. And what we are going to take a look at right now is called integration by parts. So suppose we have this. We want to integrate x times x plus 1 half dx. So why don't you guys pause the video here and try and integrate this. I use whatever method you're comfortable with. You can use the substitution method or however, and give it a go. Okay, so hopefully you've tried to solve this, integrate this, and found out that we cannot use the substitution method here. It's not going to work out. And as a result, what we are going to have to do is use integration by parts. So here's what we do, okay? Let me introduce you guys to a formula first. You guys must remember this formula. Differential of uv is equal to v times du plus u times dv. You've all done chapter 7 and 8. 8, I think this is in chapter 8, so you should remember from there. Now, suppose we want to integrate this, all right? So we integrate both sides. uv equals to integration of v du plus u dv, right? So now we have integration and a differential. So this ends up becoming uv equals to integration of v du plus integration of u dv. So what we can write effectively is that integration of v du is equal to uv minus integration of u dv. And this is the formula that we are going to use to solve this problem. Okay. So of course, notice here we have both u and v. So instead of assuming, let's say, x equal to u or something, we're going to have to assume values of both u and v. Okay. So let's start off by assuming, or let's suppose, let's assume that x is equal to v and 2x x plus 1 to the power 3 by 2 equals to u. If we have this, what we also have is that dv is equal to dx and du is equal to how much will we get if we differentiate this with respect to x? We get x plus 1 to the power half, which is what we have here. And so now we're ready to start integrating. So integration of x plus 1 half dx is equal to how much? Okay, so of course, yeah, that was, what was it? We have a dx right here. So x is v, x plus 1 to the power half dx is du. We're trying to integrate v du. V du. This is equal to what? uv minus integration of u dv. we know these values. We know what u is, we know what v is, and what we will get is 2 by 3 x plus 1 to the power 3, sorry, 3 by 2, which is u, times v, which is x, minus integration of u, which is 2 by 3 x plus 1, 3 by 2, times dv. dv is how much? dv is dx. So it may look complicated, yeah, but at the end of the day, all we are doing is we're substituting values. So if we do this now, we have 2 by 3x, x plus 1, 3 by 2, minus, all right, so if we integrate this, we are going to get x by 2, 3 by 2 to the power 1, divided by 3 by 2 to the power 1, have 2 by 3 here, plus a c. So what this becomes is 2 by 3x, x plus 1, 3 by 2, minus, this will be 5 by 2. Okay, so that means that what we are going to get is 2 by 3 times 2 by 5 times x plus 1, 5 by 2 plus c, of course, and so by 3x, x plus 1, 3 by 2, minus 4 by 15, x plus 1, 5 by 2 plus c, and that is the answer. So we're trying to integrate x plus 1 to the power half dx, and this is our answer. So it looks complicating, but let's review all that we've done. First of all, we've introduced a new formula. Okay, so just remember this formula, and if you do that, all we've done here, let me use a different ink, we've assumed that x is equal to v. We've assumed that this is equal to u, and then we've differentiated them. So dv is equal to dx, and du is equal to basically differentiation of this times dx. And having done that, all we've done, so this was x, this was u. And having done that, all that we've had to do is just replace the values here. So we know x is v, x is v, we know this entire thing is du, and then this is this. So as a result, we were able to plug this in, and then we know the values of u and v and u and dv. It's just replacing, and then just basic algebra. So obviously, I know this looks a bit daunting and a bit difficult. I will be solving a few more problems in the next video. But before that, it will help if you guys try to solve a few problems on your own. So just pick any problem from the book, can be from the exercise, can be from the worked out examples, and try to solve a couple of problems on your own before you come to the video and try and see and look at me solving more problems. I think that will be more helpful.